In ancient times, people saw the stars as a sphere enclosing the planet and the dwelling place of gods. Later, in the medieval ages, the Greeks were the pioneer to see stellar happenings as a phenomenon that could be studied by humans. A Greek philosopher and astronomer, Anaxagoras, proposed that meteors are formed of ingredients present on Earth, and hence the Earth may have originated there. The foundations of these astronomical studies were laid by those early astronomers. However, they would be astounded by today's discoveries produced by their followers. These stars and planets, which were once homes of the gods, are now considered as insignificant components of a huge framework of matter and energy that stretches far into space. We started making the most significant discoveries after 1920. In the 1920s, astronomers Edwin Hubble and Milt Hermansen were investigating the light of hazy patches of nebulae in the sky. This research used the massive new 100-inch Hubble Telescope, the most advanced space telescope of the time, on Mount Wilson, California. They discovered that these hazy patches were the faraway galaxies far beyond our Milky Way. Moreover, they also discovered that the majority of these galaxies were traveling away from us. As they looked further into space, they witnessed that these galaxies were retreating faster. Hubble implied a law after an investigation that there must have been a period when all of the stuff in these galaxies was concentrated in one location. It is known as Hubble's Law. In simple terms, everything that astronomers see through their telescopes can be traced back to a single origin. Later investigations term this phenomenon as the Big Bang. In 1917, Albert Einstein predicted the cosmos would expand. Based on Einstein's general theory of relativity, galaxies were moving apart due to the expansion of space. As a result of this, when a photon is ejected from a distant star, it travels across an already growing cosmic landscape, and thus increases the distance between the star and the Earth. Therefore, to determine the size of the universe since the Big Bang, we need to know how long this phenomenon of growth has taken place. Data derived by the Hubble Space Telescope and other instruments led to a conclusion that the emergence of the universe is 13.7 billion years old. Therefore, a beam of light may have traveled 13.7 billion light years. This equates to approximately 1.3 quadrillion kilometers. Scientists have been continuously exploring space, taking into consideration the expansion of the universe. The most distant galaxies that were observed by the Hubble Space Telescope were 46 billion light-years away in each direction, and about 92 billion light-years away from each other. Is it the maximum size of the universe? The answer is no. According to a new theory that describes the beginnings of the universe, our 92 billion light-year distance is just a tiny dot-like portion of the whole universe. This theory was based on the observation that energy in the form of photons, neutrons, matter and antimatter is constantly bubbling up from the vacuum of space. In the 80s, Alan Guth, a physicist, claims that energy fields in space's vacuum had unexpectedly flipped into a higher energy state. This has inflated space and time. Moreover, this proved that over an infinitely small period, space has grown from atomic to cosmic scale. The universe as a whole includes the observable and unobservable universe. According to Guth, the unobservable universe has grown to 10 billion trillion times. That's 10, followed by 24 zeros in size, compared to the size of the observable universe. That is 10 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. Astonishing, right? To simply describe the observable universe is an atom compared to the whole universe. The notion that our universe expands unevenly complicates these calculations even further. The European Space Agency stated in 2020 that the universe is expanding unevenly in all directions, based on evidence from several observatories. The researchers matched the brightness of thousands of galaxy clusters to their X-ray temperatures. Some clusters looked to have less light than others, implying that they were not traveling at an even speed. According to ESA, the enigmatic dark energy would be the reason for this uneven cosmic expansion. Humans may appear to be at the center of the universe. It is like assuming that the Earth is at the center of the universe. For example, if a ship is traveling in the ocean and cannot see the land, it doesn't mean that they are at the center of the sea. Similarly, we cannot define the position of the Earth, solar system, and galaxy in the vastness of the universe. The immensity of the universe is interpreted in several ways by scientists. It can be measured by studying the cosmic microwave moving in the background after the Big Bang. Moreover, it can also be measured by using Type 1a supernova standard candles. But all these techniques of measuring will only give us a rough estimate of how big the universe is. The rate at which this inflation is evolving has also become a great mystery. As assumed by the scientists, it was 90 billion light-years based on the assumption that the rate of inflation was constant. But many scientists believe that it is slowing. In the 1980s, Alan Guth estimated it to be 10 sextillions if the rate of inflation would be at the speed of light. According to NASA, these mysterious events of dark energy may have influenced the expansion in the seconds following the Big Bang. Rather than using a single measuring technique to estimate the size of the Earth, Miran Vardanyan, along with his colleagues at the University of Oxford, analysed all of the findings statistically. They used an averaging Bayesian model that considers how plausible a measuring technique is to be accurate, given the data, rather than how well the measuring technique fits the data itself. You'll be amazed to hear what they discovered. Miran Vardanyan and his team discovered that the universe is at least 250 times bigger than the universe that is observable through telescopes. Yes, you heard that right. This approximately equates to 6.8 trillion light-years. This calculation is quite big, but it is less compared to the estimates given by other techniques. The shape of the universe has a significant impact on its size. According to scientists, either the universe is spherical, infinite, or curved like a saddle, or it is flattened and infinite. According to the laws of physics, a finite universe will have a finite size that would be measurable. On the contrary, an infinite universe has no size. As of 2013, NASA scientists have determined that the universe is flat, with a margin of error of about 0.4%. This discovery can alter our perceptions of the size of the universe. Conclusively, the universe is infinite in size, but as the universe is finite in age, we can only see a finite portion of it. The whole universe is a multiple of the observable universe. In the end, we'll leave you with another mind-boggling assumption made by the physics department at the University of Oregon. They think that the seemingly limitless universe is deceiving us, just like a hall of mirrors. Light wrapped several times in space generates numerous reflections of each galaxy, which makes it look like the universe is infinite. Let us know what are your thoughts about this in the comments section. In 2021, NASA launched the James Webb Space Telescope. This measures the size of the universe by studying infrared wavelengths. As a result, we will be able to get accurate measurements unaffected by the particles in the space. Just 5 centuries ago, we believed the Earth was at the center of the universe. Thanks to the invention of telescopes, it helped us see distant stars, galaxies, clusters of galaxies, and huge walls and filaments of matter beyond them. Extending our perception of the universe far beyond our horizon has given birth to new conceptions about the vastness of the universe. It seems that these discoveries have pushed our planet into a smaller and smaller corner of creation. We hope you enjoyed the video. Don't forget to share this video with your space fanatic friends who would love to know about the size of the universe. Subscribe to our channel and click the bell icon to get notified of our newest videos on such interesting topics.